Now, before we graph our polynomials, let's talk about this section of your notes really quickly. This section of our notes says that a polynomial graph will always be continuous and smooth. Basically, what's that saying is when you graph these polynomials, you should be able to graph them from start to finish without ever lifting your pencil. So that's continuous. You never lift your pencil the whole time. Another way of thinking about that is these graphs will not have any asymptotes in them. If you've graphed with asymptotes before, that is chapter 3. That's what we'll be doing next. But these graphs are continuous. No asymptotes, no breaks in the graph. So when we go to graph these, we'll keep that in mind. Now, I know the next part of your notes is the intermediate value theorem, but I would like to come back to that at the end and start graphing polynomials right away. This is the biggest, most important part of the lesson, is graphing polynomials. So this is what I want to focus on. Now, hopefully you'll notice very quickly that this equation we've been given is given to us in factored form, which means the x-intercepts are easy to find because I take both factors, set them equal to 0, solve, and when I solve them out, that gives me my x-intercepts. So if I wanted to come and graph this, I'm going to have an x-intercept at -3 and an x-intercept at 2. Those are the places where I cross the x-axis. Now, I should actually probably fix my wording a little bit. Let's talk about x-intercepts for a second. When you have an x-intercept, you have two options of what the graph could look like at that point. You could, number one, cross through the x-intercept. That's your first option. Or option number 2, you could come to the x-intercept and bounce off of it. Those are the only two options you've got at x-intercepts. You either cross through or touch and bounce off. Now, the next question we need to ask for graphing is how do I tell which one is which? That happens with something called the multiplicity of the x-intercept. So the multiplicity is the exponent on the factor. So let's come up here and let's talk about the multiplicity of these x-intercepts. The multiplicity is the exponent on the factor. So if I look at this factor first, notice that the exponent on this factor was a squared. So it has a multiplicity of 2. Now if I come over to this factor is going to have that secret exponent of a 1. So it has multiplicity of 1. Now, that's how you find multiplicity, but how do we use it? Well, I want you to think about it this way. If I look at this one and it's being squared, well, we just talked an awful lot about things that are squared. We know that x squared, the graph of x squared, looks like a parabola. We've gotten very good at those. So, if this x-intercept has a multiplicity of 2, an exponent of 2, that means at this x-intercept, we are going to bounce off of it. Make it look like a parabola at that x-intercept. Because it's squared. It's that parabola shape. So that gives us the bouncing. Next, here, with my multiplicity of 1, if you think about multiplicity of 1, that's like a linear. A linear goes straight through. So this intercept will cross through this intercept. Cross through that intercept. Because it has a multiplicity of 1. So basically, to summarize, If the multiplicity is even, the graph touches and bounces at that x-intercept. If the multiplicity is odd, it crosses through that x-intercept. And we know that because evens make parabolas. X squared, x to the fourth, x to the sixth. If you graph all those graphs, they're parabolas. Whereas odd makes cubics or linears. Those go straight through. So what I like to do when I graph is come here. Well, I think I erased too much. And I'm going to put a little b next to this x-intercept so that I know I'm going to bounce off of it. And I put a little c next to this x-intercept to know I'm going to cross through it. So let's talk about graphing this then. Let's say that I tell you that this graph is going to start down here. And you may ask, well, Mrs. Johnson, how do I know where it starts? That's actually the next thing we're going to learn in the next video. So hold your horses on that. We'll come back to that in just a second. However, if I know I'm going to start down here, that means the arrow of my graph should point down to there. So now I'm going to come up to this x-intercept, and I'm going to bounce off of it. Then I'm going to circle around to this x-intercept, and I'm going to cross through it. And that's your graph. You're done. That's all you need to do. Now, one thing I've had a couple students ask about is how do I know how far down this should go? You actually don't. To find that is actually a calculus thing using derivatives. So for this class, we don't care about how far down you make this part go. We just need it to go through that, and we'll need it to cross through wherever the y-intercept actually is, which we'll find in just a second. So I know I bounce and I cross. Now, before we talk about the y-intercept, the next thing I want to talk about, this is a very common mistake that I see students make, is they'll say, okay, I bounce, and then I come like this, and then I cross, and I'm done. And they're like, hey, I bounced there, I crossed there, I'm good to go. However, there's a problem with this graph because you have now created a third x-intercept. This graph didn't have a third x-intercept. There's no x-intercept there. So that is why that does not work. We have to bounce off this one, circle around to the next one, cross through that one. So there we go. So then we're going to talk about how to find our starting point. That is going to be the next video. In the next video, we'll talk about finding our starting point and how we do that.